Okay, students, today we will talk on electrostatics. The word electro comes from electron, means charge. Static means stationary. Today we will speak the charges, those are at stationary, called electrostatics. Okay, we have seen there are two types of charges. Okay, one is positive charge, one is negative charge. The best example for positive charge is proton. The best example for negative charge is nothing but electron. These are mainly two charges which we have to talk. Proton positively charged, electron negatively charged. Generally, charge will be denoted either by Q, small q, or capital Q, both, no problem. Either you denote it by capital Q or you denote by small q, no issue in that. Okay, so now we have seen what is the charges. There are two types of charges and it is denoted by positive Q and negative Q. Now its SI unit. Its SI unit is Coulomb. Its SI unit is Coulomb. The standard book will denote by C. It will be denoted by C. Then it has another unit called ESU, which is called electrostatic unit. Electrostatic unit. 1 Coulomb is equal to 3 into 10 की power 9 ESU. I repeat, 1 Coulomb is equal to 3 into 10 to the power 9 electrostatic unit. Stop. Next is quantization of charges. Quantization of charges. Correct? Charges on any body will be appear in the form of, always remember, Q is equal to plus or minus Ne, means integral multiple of basic charge of electron. I repeat, integral multiple of basic charge of electron. Okay, means here n will be nothing but 1, 2, 3 and so on. Okay, you take integral numbers. Okay, positive sign will indicate for positive charge, maybe proton, deuterium, like that. Negative charge is negative sign, generally will denote negative charge, means very famous electron. Means if I will say plus 1 E, means 1 proton. If I will say plus 2 E, means 2 proton, like that. Okay, if I will say minus 1 E, means 1 electron. Okay, here basic charge of electron is 1.6 into 10 to the power minus 19 Coulomb. Basic charge for electron is 1.6 into 10 to the power minus 19 Coulomb. Next is conservation of charges. Conservation of charges. Okay, very similar to conservation of energy. In conservation of energy, since school level we are saying energy cannot be created, cannot be destroyed, can be transferred into one form into another form, and the total energy of universe remains constant. Here we have to speak a little bit in different fashion. He says that charge cannot be created, cannot be destroyed, but can be created or destroyed pairwise, and total charges of isolated body means there is no external effect on that body, remains always constant. I repeat friends, here he says that charge cannot be created, cannot be destroyed, but can be created or destroyed pairwise, and the total charges on isolated body remains constant. Now we'll see electrification of charges. Electrification. Number one. First is due to friction. Okay, when there are two insulating body rub with one over another, okay, there will be creation of charges. Okay, now how the charges will be created pairwise, have a look here. Suppose I will take two bodies. Suppose body A, suppose body B. Okay, first we will speak about the friction. Friction. Okay, suppose in first body there are electrons. In second body again there are electrons. Here suppose the electrons are bound with body 1, okay, with energy Wa called work function. Suppose its work function is Wa, energy with which the electrons are bound there. Suppose here the work function is Wb, and I says Wa less than Wb, means what? Here the electrons are bound with lesser energy beta. The energy is less as compared to this. When you start rubbing, what will happen? Due to kinetic energy, here the work function is less. The electron will transfer here. Have a look. When the electrons deficiency is there, number of electrons becomes less. This becomes positively charged body, and here that due to excess of electron will increase, it becomes negatively charged body. Just have a look. अभी आपने बोला that the charges create pairwise, plus minus. Only plus will come, generally not possible. Only minus will come, generally not possible. Where the deficiency of the electron take place becomes positive charged body. Where the excess electrons are there become negatively charged body. Correct? This is the charge creation due to friction. In some books it is called frictional electricity. Frictional electricity. Okay, in daily life, generally in, you can say, north, especially Delhi, Rajasthan, in winter, sometime if you just open the door of car, you will get shocked. Even sometime in Mumbai also, you touch your friend, you will get shocked. This is purely best example of electrostatic due to friction. There should be dryness. I repeat, there should be dryness. Okay, if suppose you will take comb and you will rub on the dry hair, correct? And if you will take the comb near to a small piece of papers, we have done in school level, the paper will stick on that. Why? Because now comb become charged. When you will rub the comb on your hair, the comb become positively charged, hair become negatively charged. Even sometime, if you will sit in the winter season in the north zone with woolen coat, sometimes there are very small spark out of the charge generation on the plastic sheets. So woolen coat will become positively charged body and the plastic sheet will become negatively charged body. Even you will take the glass rod and you will rub on the silk cloth. The glass rod becomes positively charged and silk cloth will be negative. These are purely example of frictional electricity. Next is due to conduction. Conduction. Here what? You are having the charged body. You have to touch second uncharged body. I repeat, you are having the one charged body and suppose you have to charge this uncharged body. Due to conduction means you have to touch the body here. What will happen? Suppose this is a charged body Q. Okay, this is the same size of uncharged body. It is uncharged. uncharged body, correct? When you will touch this body, okay, of course, size are same. Suppose your sizes are same. Okay, what will happen? Exactly half of charge will go here. There was a Q Coulomb. So what will happen? After just touching, this will become Q by 2, this will become Q by 2. And when you will separate this both becomes Q by 2. Means this is also get charge. Correct? If you will say, suppose sir, there will be sizes are not seen, that will be seen in capacitor. Of course, the second part of electrostatics. Okay, here we are assuming that the size of the bodies are same. Okay, suppose, I repeat, suppose this body has charge Q1. Suppose this body has charge Q2. This body has charge Q1. This body has charge Q2. When you will touch this body, both will get Q1 plus Q2 divided by 2. This will be Q1 plus Q2 divided by 2. Both will give half of this, because here this was not uncharged body, it was also having the charge beta. So total charge is nothing but Q1 plus Q2. Both will have half, because again I am taking the similar body. Okay, now this is the third and final, you can say, the method for electrification part of it. It is called induction. Okay, suppose there are two uncharged spheres. Okay, I kept like this, of course more or less identical. Okay, bring any positively charged source here, maybe the glass rod, just get close to it, don't touch. You will find there will be the negative charge developed on nearer face and positively charged exactly opposite of this on the farther face. Now just make them separate, not very large distance, just separate. Okay, you will find same scenario, minus and plus charge. Okay, now remove the glass rod. जो glass rod लाया था, just remove that. Okay, you will find this will comes to this side, negative charge, and this will come to this side, so that there will be attraction part of it. Okay, now take them at a larger distance, separate them with a quite sufficient distance. You will find the negative will be distributed uniformly. Here positive will be distributed uniformly. Earlier there was no charge, correct? Now both body get charged. This is negative, this is positively, uniformly charged. You have not touched the glass rod, therefore it is called induction. Due to induction, the charges pairwise develop on the spheres. Coulomb force. Coulomb force. If suppose I will take 2 point charges Q1, Q2 at a distance r, from it. Okay, if these two are like charge, means both are positive, either both are negative, they will repel each other. जैसा मैंने I have taken both positive, correct है? They will repel each other. Okay, if they are unlike, means if one is positive, second is negative, or first is negative, second is positive, they will attract, correct? Here I have taken both positive, definitely I will show repulsion. Okay, Coulomb says that force will be directly proportional to product of charges. He says that it will be inversely proportional to square of distance between them. When I will club this becomes Q1, Q2 over R square. When I will remove this sign, proportionality sign, I will put one constant. That's very important. Here the constant will be 1 by 4 pi epsilon. Here constant will be 1 by 4 pi epsilon. Okay. Q1, Q2 over R ka square. Here epsilon, I repeat, epsilon is called permittivity of free space. Permittivity of free space. Now what is that? That's very important. Suppose I will put any charge here. So this space is having how much ability to store its effect, to store, I repeat, its effect in the form of electric field. अब सिंपल लैंग्वेज में बेटा मैंने एक चार्ज यहां रखा, ये मीडियम, आई रिपीट, ये मीडियम उसको कितना झेल पाएगा, उसको कितना बर्दाश्त कर पाएगा. ओके, तो टेक्निकली वी कॉल इट इज द एबिलिटी ऑफ मीडियम टू स्टोर एनर्जी in the form of electric field. Definitely एयर की एबिलिटी अलग होगी, कैरोसिन लोगे उसकी एबिलिटी अलग होगी, हाइड्रोजन गैस लोगे उसकी अलग होगी. तो इट इज कॉल्ड परमिटिविटी ऑफ फ्री स्पेस. ओके, इट्स टोटल वैल्यू, आई रिपीट, इट्स टोटल वैल्यू विल बी नथिंग बट 9 into 10 की पावर 9, 9 into 10 की पावर 9, एंड एसआई यूनिट विल बी बराबर, देखिए इट इज न्यूटन, this will be meter square, coulomb square. So SI unit will be Newton meter square per coulomb square. Okay, only epsilon value will be beta 8.85 into 10 की power minus 12. 8.85 into 10 की power minus 12. You should not worry it. This also will be given in the question paper. This will be also given in the question paper. Don't take tension for by hiding this, okay, but you should know 8.85 into 10 की power minus 12. Its SI unit will be exactly opposite of this, means reciprocal of this, coulomb square over Newton meter square. That's called Coulomb force. Okay, now we will see in the medium, Coulomb's law we will see in the medium. Okay, in medium, in medium, when we will speak about the medium, I repeat, when we will speak about the medium, we will give you relative permittivity of medium, or it is also called dielectric constant, both. Okay, epsilon r या k, I will make the habit of k, I repeat, I will make the habit of k, not epsilon r. Okay, both you can call, it is called relative permittivity or it is called dielectric constant. Or it is called dielectric constant. Okay, what is dielectric? We'll see again in the capacitance in the next lecture, not now. Dielectric constant. What is that? बराबर सुनिए. Epsilon m divided by epsilon naught is called k. Means permittivity of medium. Epsilon means permittivity of medium. Epsilon means permittivity of medium, okay, divided by permittivity of free space. So from here medium will be nothing but k into epsilon. Okay, the medium's permittivity becomes k into epsilon. Now we will say force in medium. M means medium. You will say, sir, q1 q2 over 4 pi epsilon into k, because here we will put the medium's permittivity. I repeat, we will put medium permittivity and it is nothing but k into epsilon into r square. Okay, this is for medium. What will change? With epsilon you have to take k. We will give you k, don't worry. Now you say force in free space over force in medium. I repeat, force in free space, force in medium. In free space you say, sir, q1 q2 4 pi epsilon r square. For medium you say q1 q2 over 4 pi epsilon k r square. This quantity cancel, this cancel. Okay, in numerator become 1, in denominator 1 by k, so it becomes ultimately k. Okay, so what you have derived? You have derived force in free space over force in medium is equal to k. Okay, this you have to by heart. I'm putting star. You have to by heart. What you have derived? Coulomb force in free space over Coulomb force in medium is nothing but dielectric constant. Second formula also for dielectric constant, permittivity in medium over permittivity in free space is called dielectric constant. Remember both the formula. What I say is permittivity of medium over permittivity of free space gives you dielectric constant. Another formula beta, force in free space over force in medium is called dielectric constant. Now we'll see the vector form of Coulomb force, because ultimately force is a vector quantity. You have to drive in vector form also. So the topic is called vector form of Coulomb force. Start. Same. Suppose this is Q1. Suppose this is Q2. Distance is R. Same thing. Okay. Only we have to put in vector form. This is called F21. That's very important. Force on charge Q2 due to Q1. And here you call this force F12. Put in the vector form bar. F12 means force on first charge due to another. Okay, I am writing, don't worry. F21, that is force on Q2 due to Q1. F12, that is force on Q1 due to Q2. Okay. Now take the unit vector here. I repeat, take unit vector here. Name this R21 cap. Cap means unit vector is magnitude 1. It will do nothing except giving the direction. Okay. Give this unit vector 1, 2. I repeat, in this direction towards right, give R21 like this, and in this direction give R12 this. Cap means unit vector. Okay, now you will say, sir, F12 is equal to vector form Q1 Q2 over 4 pi epsilon R square into R12 cap. Just remember guys, in this direction, which is a unit vector running, R12. Give R12. Now again F21 will be nothing but Q1 Q2 over 4 pi epsilon R square R21. In this direction it is running. That becomes vector form. Now you notice both magnitudes are same. Only the directions are opposite. So what I can conclude, F12 is equal to F21. Lekin minus. Why minus? F21 acting in this direction and F12 is acting in this direction. Okay, so this was all about the Coulomb force in the vector form. Now we'll start superposition theorem. Superposition theorem. What is that? Suppose I will take the charge Q here. Okay, I am having charge Q1 at a distance R1. I am having charge Q2 at a distance R2. I am having charge Q3 at a distance R3, and maybe there are many charges. No issue. Okay. Now here the net force, or you can say the total force, will be nothing but simple vector sum. Student, I repeat, vector sum of all forces. So F net on Q will be given by, just see, due to this, देखिए repulsion here F1, due to this repulsion here F2, due to this repulsion here F3, all repulsion, because both are positive, they will repel. So here the direction will be, have a look, here due to this, here due to this, here, and you will say F1 plus F2 plus F3, all are bar. This is about vector form. This force will be nothing but Q1 Q2 over 4 pi epsilon R square, say R1 cap, R1 square I should say, sorry, R1 square, R1 cap means you have to show in the vector form, Again, put this Q, Q1, then Q2 over 4 pi epsilon R2 square, R2 cap. Then Q3 over 4 pi epsilon R3 square, R3 cap. Okay, just have a look at that. First pair. Have a look. Second pair. Have a look. Third pair, like this. Okay. Don't forget to put bar as the vector sign. Okay, whatever we thought so far, we will just have some basic example on that. Some, you can say, the assignment on that. Okay. Suppose this is a spherical charge body Q1. Suppose this is a spherical charge body Q2. They kept at a distance r. You can say the first numerical part of it. Okay, of course, we are going on numerical part now. Q1, this is suppose Q2. The distance is r. What he says that? He says that touch both the body. Both are identical body. I repeat, both are identical body. Touch both of them. दोनों बॉडी को बेटा टच कीजिए. Okay. Then keep both body at the same distance. Okay. Suppose here the force was F. Here suppose the force was F. Now the new force after touching, just separate this. Suppose force is F dash. Force is F dash. And your job is to calculate F dash. Of course, you have to keep same distance. Okay. Now start. First of all, when you will touch this, both charge will become what? Q1 plus Q2 half. Q1 plus Q2 divided by half. Both will become. All are agree with this? Both will become Q1 plus Q2 by half, and this is also C. Okay. Now start. Here, force was Q1, Q2, 4 pi epsilon r square. Say equation 1. Here, force will be, बराबर देखिए, Q1 plus Q2, okay, into Q1 plus Q2 half divided by 4 pi epsilon r square. Okay, now this will become Q1 plus Q2 whole square divided by 4, 2 2s are 4, into 4 pi epsilon r square. Say equation 2. So this equation 2. Now say 1 divide by 2. So you will get F over F dash. Have a look, beta. F here, F dash, first equation, okay? It is a F dash. Okay. This 4 pi epsilon r square, this 4 pi epsilon r square will cancel. Okay. What will be left out in numerator? Q1, Q2. What will be left out in denominator? Q1 plus Q2 whole square. This will go in numerator. Come forward. Okay. Now, F dash will be what? F dash will be, just make the cross multiplication. F into Q1 plus Q2 whole square divided by Q1 Q2. सिर्फ cross multiply कीजिए. Take this here. Take this in the denominator. Your F dash will be, that is nothing but new force. Now start. Second example, whatever we thought here. Suppose I will put the three charges Q, Q, Q. Okay. At the vertices of equilateral triangle. Suppose length is L, L, L. Correct? Equilateral triangle, but natural. All angles are 60 degrees. Aware of it. No. He says that find net force or any one vertices due to another two charges. Suppose I have to calculate this force here, force I have to calculate here. Okay. Now before going to start this, we will speak about the basic some vectors rule. If this is vector A, suppose this is vector A, same vectors, they are 60 degree apart, the resultant vector magnitude will be A root 3. Okay, it comes from the parallelogram law. Of course, we are not going in that depth here, but it comes from the parallelogram law. R is equal to A root 3. Remember. Okay, now start. Due to this, first have a look. Repulsion here, force F. Due to this, the repulsion here, force F. What will be one force? I repeat, what will be one force? Q1, Q2 divided by 4 pi epsilon L square. Correct? Okay, L square. So what you say, sir, this is F. Sir, this is F. So here F net will be what? F net will be what? F root 3, because angle is how much? 60. Okay. So your F net will be what? Q square. Okay. Q1, Q2, that is Q, I'm sorry. Divided by 4 pi epsilon L square. Okay. Just multiply by root 3. This will be net force on this. The third basic example we will see. Suppose I will take charge Q2. I will take charge Q2 and at a radius R, I will revolving negative charge. I will revolving negative charge in the circle. Okay. You have to find out the time period. What is the time period? In circular motion we have thought time to complete one revolution. I repeat, time to complete one revolution is called time period. You have to calculate that. Okay, now start. The first concept here, always Coulomb force, that is nothing but Q1, Q2. Have a look. It is a minus, it's a plus. That will be attraction over 4 pi epsilon R square will be nothing but centripetal force. That's a very important bit. In circular motion we thought that always force on the electron around the nucleus is centripetal force. Correct? So Coulomb force is nothing but centripetal force. This is the first concept. Okay. R and R cancel. V square will be what? Q1, Q2 over 4 pi epsilon. Okay. 1R divided by M. Okay. So V will be nothing but Q1, Q2 over 4 pi epsilon R into M. It is nothing but velocity. It is also called orbital velocity. Of course, he is not interested in that. Forget it. Okay, now what is the time period? Velocity is equal to, you say, distance divided by time. In complete one revolution, distance is 2 pi r, time period is called capital T. So T will be what? 2 pi r over, V will be in denominator. Denominator mein, this will be in under root. This will be in under root, because the square of this will be under root. Q1, Q2 over 4 pi epsilon R into M. Okay. Take this in the numerator. So T will become 2 pi R under root 4 pi epsilon R into M divided by Q1, Q2. Okay. Take everything inside. So T will become, okay, it will go inside 4. 4 4s are 16. Pi, it will go inside pi square and 1 pi cube. R, it will go inside r square and 1 r cube. Epsilon into M. Whole divided by, I repeat, whole divided by Q1, Q2. Once again, 2 will go inside, will become 4, 4 4s are 16. Pi will go inside, pi square 1 pi cube. R will go inside, r square into r cube. epsilon as it is, m as it is, divided by this whole divided by q1, q2. That will become time period. This much time will take q1 to revolve around the q2. Okay, now we'll see the next example. Here, he has given you two spherical charge body. Okay, both having same mass and charge, m and q. They are in equilibrium. Equilibrium means beta, net force becomes zero, net acceleration becomes zero. That's called equilibrium. In this way, okay, the thread which supporting the sphere, which supports the sphere, is of length L. This is the situation. Okay, he is asking find charge Q. I repeat, he is asking find charge Q. कितना charge होगा जब ऐसा आके दो charge sphere रुक जाएंगे. Okay, start. First of all, here there will be Coulomb force. Okay, suppose this distance is x. So Coulomb force will be nothing but q1 q2 means q square. Both charges are same, divided by 4 pi epsilon x ka square. Okay, here this is the hypotenuse, this is the angle. So opposite side, this much will be L sine theta. So x will be what? Here x will be what? 2L sine theta. This is L sine theta, L sine theta. Both will be 2L sine theta. Now force will be q square divided by 4 pi epsilon into the bracket 2L sine theta ka square. This is nothing but force. That's called Coulomb force. Let's stop here for 2 minutes. Okay, that is nothing but called Coulomb force. कुछ सेकंड्स के लिए रुकता हूं, बराबर देखिए यहां तक. Agree? Okay. Now we'll make its FBD. Weight will be downwards. Here, this will be tension. This angle is theta. This will be also theta. You call this alternate angle, making Z beta. This will be T cos theta. This will be T sin theta. Around say. We'll wait for a few seconds. T cos theta where the angle is, and perpendicular to this is T sin theta. Okay, now we'll make the equilibrium equation. This force and this will same, so you will say F is equal to T sin theta. Say equation 1. Then we equate weight is equal to T cos theta. Okay, weight is equal to T cos theta. So you will say mg is equal to T cos theta. Okay, it is called horizontal equilibrium. It is called vertical equilibrium. So equation 2. Say 1 divide by 2. 1 divide by 2. T and T will cancel. Okay, here left out will be tan theta. In left hand, left out will be F over mg. Okay, so F is equal to mg tan theta. Very important instruction, very important expression, very important. In this type of sum, always Coulomb force will be weight into tan theta. I repeat, weight into tan theta. It is nothing but Coulomb force. Okay, now in spite of Coulomb force, just like this. Okay, so this will be q square over 4 pi epsilon 2L sine theta ka square is equal to what? mg tan theta. Okay, so q square will be what? mg tan theta into 4 pi epsilon 2L sine theta square. Okay, what I did, I have taken everything here. Okay, just multiply it. 4, 4, 16. Correct hai? Pi epsilon. Okay. L ka square. Okay. mg. Sine square theta into tan theta. Okay. Take it into under root is equal to q. So charge on the sphere will be what? 16 pi epsilon L square sine square theta tan theta. Okay, now friends, I am giving you two small assignments, okay, for home. What is the assignment? Have a look. Suppose this is a ring, okay, on which the charges capital Q uniformly distributed over the ring. For example, this is a ring. I have distributed positively charged Q uniformly here. Radius is capital R, okay, and I put the another charge small q at center. The tension in the string will increase. You have to find increase in tension. Find delta T म्हणजे increase in tension. You have to calculate. This is the first assignment. Now second assignment. I am taking the one rod. ये rod लिया बेटा. Okay. Uniformly charged plus Q. इस पे I put the positive charge plus Q. Length of rod is L. Okay. And at a distance small r from one end, I took the point P. Charge is kept Q. You have to find force on Q. You have to find out force on Q. That's your job. Okay. This two assignment you have to do from home. Whatever we thought, that's purely based on this.